Hello friends, continuing with the topic of errors, today we take up combination of errors. If we do an experiment involving several measurements, the errors introduced in all measurements combine together during mathematical operations like addition, subtraction, multiplication and division. For example, suppose density of the given cube is to be measured, that is, rho is equal to m by v, which is equal to m divided by length into breadth into height of the cube. Now, this division involves two physical quantities, mass and volume. And volume involves three lengths, length, breadth and height. And now let us see errors introduced. If errors are introduced in measurement of mass as well as in length, breadth and height, then what would be the error in density? These errors combine together while calculating final result. The question is how these errors combine during addition, subtraction, multiplication and division. Let us take up one by one. First we take up addition case. Suppose two physical quantities are to be measured whose true values are A and B. During addition, the combined true value, say Z, would be equal to A plus B. Let delta A be the absolute error introduced in A and delta B be the absolute error introduced in B. Then measured values of A is A plus delta A and that of B is B plus delta B. Now after addition, the combined value will be Z plus delta Z is equal to A plus delta A plus B plus delta B, and it is equal to A plus B plus delta A plus delta B. We can write A plus B as Z, so we can express this as Z plus delta A plus delta B. Mark it as equation 1, where delta Z is the combined error during addition. Now from equation 1, we have combined error delta Z is equal to delta A plus delta B. I repeat, from equation 1, we have combined error delta Z as delta A plus delta B. Let us take up case of subtraction. Suppose two physical quantities are to be measured whose true values are A and B. During subtraction, the combined true value, say Z, is equal to A minus B. Let delta A be the absolute error introduced in A and delta B be the absolute error introduced in B. Then measured value of A is A plus delta A and that of B is B plus delta B. Now after subtraction, the combined value will be say Z plus delta Z is equal to A plus delta A minus B within bracket B plus delta B, or it is equal to A minus B plus delta A minus delta B, or Z plus minus delta Z. Here we have introduced plus and minus because both are possible. So Z plus minus delta Z is equal to Z plus delta A minus delta B. Let us mark it as equation 1, where delta Z is the combined error during subtraction. Now, combined error after subtraction. So, from equation 1, we have combined error delta Z is equal to delta A minus delta B. Thus, in general, the combined error is plus minus delta Z, which is equal to plus minus delta A plus minus delta B, because error could be on the plus side as well as the minus side. Okay, so that's why we put plus as well as minus. Thus, in general, the combined error is plus minus delta Z, which is equal to plus minus delta A plus minus delta B. If it is a case of addition, we have plus. If it is a case of subtraction, we have minus. Now, assignment 2.3 continued. Question number 7. The two physical quantities whose true values are A and B are measured to be as number 1 A plus delta A and B minus delta B. Second, A minus delta A and B minus delta B. Calculate the combined error when these are added, when these are subtracted. Now, question number 8. Two resistances R1 equal to 100 plus minus 3 ohm and R2 equal to 200 plus minus 4 ohm are connected in series. Find the equivalent resistance of the combination, and it would be 300 plus minus 7 ohm. Now, in series, when resistance are connected, they add up. Okay. Let us take up the case of multiplication. Consider two physical quantities whose true values are A and B. Suppose their multiplication is, say, Z equal to A into B. Let us mark it as equation 1. Suppose the measured values of A plus delta A are A minus delta A, and that of B plus delta B are B minus delta B, where delta A and delta B are the errors introduced between A and B respectively. If delta Z be the error combined after product, then resultant product, say Z plus minus delta Z, is equal to A plus delta A within bracket into B plus delta B within bracket. It can be put as A into B plus delta B plus delta A into B plus delta B. Which is equal to AB plus A into delta B plus delta A into B plus delta A into delta B. And it is equal to Z plus A into delta B plus delta A into B plus delta A into delta B, or plus minus delta Z. Z will cancel, this Z and this Z will cancel. So, we are left with plus minus delta Z equal to A into delta B plus delta A into B plus delta A into delta B. Dividing both sides by Z, we get plus minus delta Z by Z, which is equal to A into delta B by Z plus delta A into B by Z plus delta A delta B by Z. Or it can be expressed as equal to A into delta B by AB plus delta A into B by AB plus delta A into delta B by AB, because Z is equal to AB. We replace Z by AB. Let us mark it as equation number 2. Now, substituting value of Z equal to AB, we get plus minus delta Z by Z equal to A into delta B by AB delta A into B by AB plus delta A into delta B by AB, which is equal to delta B by B plus delta A by A plus delta A by A into delta B by B. Now, since delta A and delta B are very small, their product delta A delta B will be still smaller. Hence, the term delta A by A into delta B by B can be neglected. Therefore, we have combined error as plus minus delta Z divided by Z is equal to delta B by B plus delta A by A. Thus, in general, we can write plus minus delta Z by Z is equal to plus minus delta B by B plus minus delta A by A. That is, the maximum combined relative error is equal to sum of the relative errors. And now discussion. If two quantities are equal, that is A is equal to B, then Z will be equal to A into B can be put as Z equal to A into A equal to A square. This is how we can substitute the value for B as A, and we can have Z equal to A square. Their combined relative error will be plus minus delta Z by Z is equal to delta A by A plus delta A by A, and it is equal to 2 times the relative error. Now, assignment 2.3 continued. Question number 9. If Z is equal to A raised to power P into B raised to power Q, calculate maximum relative error. Question number 10. A physical quantity P is related to two observations A and B as P equal to A cube into B square. The percentage errors of measurement are 1% and 3% respectively. Calculate percentage error in quantity P and it would be equal to 9%. I hope you can crack these two problems on the basis of the text that you have learned. Now, case of division. The case of multiplication is also true for division, because division is a multiplication with inverse power. Consider two physical quantities whose true values are A and B. Suppose their division is, say, Z equal to A by B. Let us mark it as equation 1. Suppose the made value of A be A plus delta A or A minus delta A, and that of B be B plus delta B or B minus delta B, where delta A and delta B are the errors introduced in A and B respectively. If delta Z be the error combined after division, then result should be, say, Z plus minus delta Z is equal to A plus delta A divided by B plus delta B, or it is equal to A plus delta A into B plus delta B raised to power minus 1, or it is equal to A into 1 plus delta A by A into B inverse into 1 plus delta B by B raised to power minus 1. Here we can take out A common, and in the second term we can take out B inverse common. Or Z plus minus delta Z can be expressed as A by B into 1 plus delta A by A into 1 plus delta B by B whole raised to power minus 1, or it is equal to Z into 1 plus delta A by A into 1 plus delta B by B inverse, because A by B is equal to Z. So we replace A by B equal to Z. Okay. Or we take out Z common here on left hand side. So Z into 1 plus delta Z by Z is equal to Z into 1 plus delta A by A into 1 minus delta B by B using binomial expansion. Because 1 plus delta B by B inverse can be written as 1 minus delta B by B on the basis of binomial theorem. Or 1 plus delta Z by Z is equal to 1 plus delta A by A into 1 minus delta B by B, because Z and Z cancels. Or you can write this expression as 1 plus delta Z by Z is equal to 1 into 1 minus delta B by B plus delta A by A into 1 minus delta B by B. Just we multiply the two brackets, and it is equal to 1 minus delta B by B plus delta A by A minus delta A by A into delta B by B. Or we can write it as delta Z by Z equal to minus delta B by B plus delta A by A minus delta A by A into delta B by B, because 1 and 1 cancels. This one and this one cancels. Now since delta A and delta B are very small, their product delta A into delta B will be still smaller. Hence the term delta A by delta B can be neglected. Therefore, we have combined error as plus minus delta Z by Z equal to minus delta B by B plus delta A by A. That is, plus minus delta Z by Z can be expressed as equal to delta A by A minus delta B by B. Thus, the minimum combined relative error is equal to difference of the relative errors, and maximum relative error is equal to sum of the relative errors. Now assignment 2.3 continued. Question number 11. A physical quantity Z is related to two observations A and C as Z equal to A raised to power P divided by C raised to power Y. Calculate maximum relative error. Question number 12. A physical quantity Z is related to three observations A, B and C as Z equal to A raised to power P, B raised to power Q and C raised to power Y. Calculate maximum relative error. Now question number 13. A physical quantity Z is related to four observations as Z equal to A raised to power 1 by 4, B raised to power 1 by 3 divided by C into D raised to power 3 by 2. Calculate maximum error. Question number 14. A physical quantity P is related to four observations A, B, C and D as P equal to A cube B square divided by square root of C D. I repeat, a physical quantity P is related to four observations A, B, C and D as P equal to A cube B square divided by square root of C D. The percentage errors of measurements in A, B, C and D are 1%, 3%, 4% and 2% respectively. Calculate the maximum percentage error in quantity P, and the answer would be 12%. Question number 15. A simple pendulum completes 20 oscillations in 25 seconds. The time is measured with a stopwatch of the least count 0.1 second. Calculate percentage error in measurement of time, and the answer would be 0.4%. So you solve these numerical problems on the basis of text that you have learned, and you will be able to solve it, I am sure. Thank you so much. God bless you.